Friends, welcome you all for the revision classes on IC engine, unit number 4 of subject basic thermal engineering, 4 mechanical engineering. The unit carries the 35 marks. In this unit, the theory will be for 20 marks and 15 marks will be for the problems. Problems. We will see some of the important questions on this unit. So here we are studying the classification of the IC engine, definition of the IC engine, the important terms of the IC engine like cylinder bore, swept volume, compression ratio, or it is in another way it is called as a nomenclature associated with the IC engine. And again we are studying the performance parameters: indicated power, brake power, thermal efficiency, volumetric efficiency, mechanical efficiency, and some more other efficiency we are studying, and working of parts of the IC engine with a neat sketch, working of 4-stroke engine and working of 2-stroke engine in the 4-stroke petrol engine and diesel engine, in the 2-stroke petrol and diesel engine, working of rope brake dynamometer and heat balance it, and some problems. In the first part of this video, we will discuss the classification of the IC engine, nomenclature of the IC engine, parts of IC engine, working of 4-stroke diesel engine, working of 4-stroke petrol engine, and the remaining 2-stroke working and difference between 2-stroke, 4-stroke, SI and CI engine, heat balancing we will discuss in the second video. So first, these are the important questions which have been repeated or asked in the previous year examinations, theoretical questions, and problems we'll see in the next video. So first we'll start. The first is, what is a IC engine? That is a define IC engine and give the classification of the IC engine. So it is, the weightage of this question is for 5 marks and it has been repeated 3 times. IC engine, generally the engines are classified as external combustion engine and internal combustion engine. External combustion engine means the combustion takes place outside the engine cylinder. Internal combustion engine means the combustion of fuel takes place inside the engine cylinder. That is called internal combustion engine. In generally it is referred as IC engine, internal combustion engine. Example for IC engine are petrol engine, diesel engine, gas engine, and etc. Now if you see the classification of IC engine, there are some of the important ways. In that ways we are classifying the IC engine. The first way of classification of IC engine is according to the fuel used. So which type of fuel we are using, based on that we are classifying IC engine as a petrol engine. If the fuel used is petrol, then it is called as a petrol engine. If fuel used is diesel, then it is called as a diesel engine. If fuel used is gaseous, then it is called as gas engine. Gaseous means CNG, compressed natural gas, biogas, or etc. Some other gases nowadays, to avoid the crisis, to overcome the shortage of diesel and petrol engine, we are going for the alternative sources. In that alternative sources, some gases we are using for running the engines. That engines are called gas engines. Next, biofuel engines, biodiesels with the different blend variations we are using here. According to the second way of classification is according to the number of strokes. If the engine takes 4 strokes per cycle, then it is called as a 4-stroke engine. In this type of engine, working cycle is completed in 4-stroke engine. 2-stroke engine, in this type of engine, working cycle is completed in 2 different strokes. Next, according to the method of ignition means the burning of the fuel, how the fuel is burned. So in that, first comes SI engine. SI engine means spark ignition engine. In this type engine, fuel is ignited by the electric spark plug located at the engine cylinder. Spark plug will ignite the air fuel mixture. So this is generally petrol engines. It is used in the petrol engines. Here the spark plug plays an important role in burning the fuels. That's why it is called as a SI engine. SI means spark ignition engines. Next comes compression ignition engines, CI engine. Compression means here instead of spark plug, the compressed air, the air is compressed and its temperature is increased. That hot air, when it comes in contact with the fuel injector, fuel where which is sprayed by the fuel injector, that fuel and hot air combustion will takes place. So here burning of fuel is taking place by compressed air. That's why it is called as a CI engine, compression ignition engine. Next classification is according to the cycle of combustion. Already we have studied the different thermodynamic cycles in the third unit. The first cycle of combustion is Otto cycle. In the combustion takes place at combustion of fuel takes place at constant volume. Second is the diesel cycle engine. In this type of engine, combustion of fuel takes place at constant pressure. Dual combustion cycle means here constant pressure and constant volume. At constant volume, both the combustion of fuel will be taking place. Next, according to the number of cylinders, how much cylinders we are using. If the one cylinder used, it is called as a single cylinder engine. If 1, 2, 3, 4, 5, 6, 8 cylinders used, it is called as a multi-cylinder engine. Next way of classification is according to the arrangement of cylinders. Arrangement of cylinders. If the cylinder is at vertical position, that is called as a vertical cylinder engine. If the cylinder is at horizontal position, that is called as a horizontal engine. If the cylinder is at inline arranged in inline, then it is called an inline engine. If the cylinder is at circumference, that is a concentric, then it is called as a radial. If the cylinder is at equally set an angle, then it is V engine. Final classification based on method of cooling. If air is used for cooling purpose, then it is called air cooled engine. If water is used as a cooling media, then it is called as a water cooled engine. The next question is parts of IC engine. The important parts need to remember are cylinder, piston rings, connecting rod, crank and crankshaft, valves, flywheel, crankcase. In the figure you can see the here is the inlet valve is there, there is a inlet port is there, outlet port is there, exhaust valve is there, and these inlet and exhaust valves are controlled by a cam, and crankcase is there, crankshaft is there, flywheel is there, connecting rod is there, piston is there, piston rings are there, cylinder is there. So these are the important parts. In the examination you have to draw this sketch and explain the some parts. So around 5 to 10 marks you will be the weightage for this question. So cylinder, it is called as a heart of the engine. Cylinder is a vessel or barrel like structure vessel where the fuel will be burned and the piston will makes its reciprocation. That means it moves from TDC to PDC. So primary function of cylinder is to contain the working fluid and to guide the piston during its reciprocating movement. Cylinder head. Above the cylinder there is a removable cylinder head which contains two valves, inlet valves and exhaust valve. Piston is there. Piston element, it reciprocates inside the, is a reciprocating element inside the cylinder, and piston rings are placed on the grooves cut on the piston. These piston rings are of two types: compression rings and oil rings. Compression rings are pressed hard with the cylinder walls and forming a tight seal between the piston and cylinder. There is a gap between the piston and cylinder wall, so that gap is filled by a tight seal which prevents the escaping of high pressure gases from the cylinder to the crankcase. Next, connecting rod. Connecting rod, it is a link that connects the piston and crankshaft. Its function is to convert reciprocating motion of the piston into the rotary motion of the crankshaft. See, next part is crank. We know that crank is a lever. One end of the crank is connected to the connecting rod and other end is connected to the crankshaft. The power required for any useful work is taken from the crankshaft. Crankcase, it encloses the crankshaft and serves as a lubricating oil sumps. So whatever the oil is coming from the cylinder, it is collected in the crankcase. Valves, there are two valves, inlet valves and outlet valve, which controls the flow of air fuel mixture into the cylinder and exhaust gases from cylinder to the atmosphere. Inlet valve is the one through which fresh charge air, only air or fuel air mixture enters into the cylinder. Exhaust valve, through which the exhaust gases are escaped to the atmosphere from the cylinder. These two valves are operated by cams. Cam is an element designed to control the movement of both inlet and exhaust valves. So next, last part of the AC engine is flywheel. It is a heavy mass rotating wheel with the heavy mass is mounted on the crankshaft. It is kept on the crankshaft, in the crankshaft kept, and it is used to store the energy or work from during the power stove, and it supplies the energy or power required during the other stove. This is the flywheel. So these are the important parts of the AC engine. So 5 to 10 marks. Next, one more, that is a nomenclature associated with the IC engine or IC engine terminology. So the different terms involved in the IC engine are inlet manifold, that is a exhaust is there. Cylinder head, we have already discussed. Inlet manifold already discussed. Exhaust port is also discussed. So what we have to discuss here: top dead center and bottom dead center, and bore, stroke, clearance volume. Clearly observe, clearance volume, stroke, bore, bottom dead center, top dead center. So this will study one by one. Bore, the inside diameter of the cylinder. Inside diameter of the cylinder is called as a bore. So this is the inside diameter. So whatever that barrel or vessel like structure that we are calling as a cylinder, that inside diameter is called as a bore. Top dead center, it is extreme position of piston's position near to the cylinder head, that is called top dead center. Bottom dead center, extreme position of the piston near to the crankshaft, that is called as a bottom dead center, and it is termed as a BDC, and top dead center is termed as a TDC. Stroke, it is a linear distance traveled by the piston. It is a linear distance traveled by the piston from TDC to BDC or BDC to TDC. In simple, we can call the piston movement from TDC to BDC or BDC to TDC. It is called as a stroke. Next, clearance volume, VC. It is denoted as VC. It is a volume of cylinder above the top of the piston. So whatever the volume left above the piston inside the cylinder, that is called as a clearance volume, and it is when the piston is moving towards TDC. So that clearance volume above the piston when piston is moving towards TDC, that is called as a clearance volume. Swept volume, it is a volume swept by the piston during its movements from TDC to BDC. Next, compression ratio, it is a ratio of total cylinder volume to the clearance volume. Total cylinder volume to the clearance volume, that is called as a compression ratio. And piston speed, the average speed of the piston is called piston speed. The piston speed is calculated by 2Ln, where L is what? Stroke length in meter. N is speed of engine RPM, 4-stroke petrol engine. Next, we will study the working of 4-stroke petrol engine and 4-stroke diesel engine. So before this, we will see one video, animation video, how that diesel engine works. Now we'll see the working of 4-stroke petrol and diesel engine. After this video, it is easy to understand. So you can see that sketch. The working of 4-stroke petrol engine will take place in suction stroke, compression stroke, working stroke, or it is called as a power stroke, and exhaust stroke. So if you see the parts already we decide. So what is the difference between that working of 4-stroke petrol engine and diesel engine? If you understand that three differences, the remaining working is same in 4-stroke petrol engine and 4-stroke diesel engine. So what is that difference? In the petrol engine, you are seeing that petrol air mixture enters the cylinder through inlet valve, but in case of diesel engine, only fresh air will enters. And second difference is, in petrol engine the spark plug is used which ignites the petrol air mixture, but in case of diesel engine fuel injector is used in place of spark plug. Instead of spark plug we are using the fuel injector, and only fresh air enters. That fuel injector will ignite that fresh hot compressed air. This is the major difference between that 4-stroke petrol engine and 4-stroke diesel engine. And again the working is everything is same. And if you observe the figures, suction stroke, inlet valve open, outlet valve is closed, piston is at top dead center, and crankshaft rotating 180 degree. Compression stroke, both valves are closed, piston is at bottom dead center. Working stroke, both inlet and outlet valves are closed, piston is at top dead center. Exhaust stroke, both inlet and exhaust valve open, inlet valve is closed, piston is at bottom dead center. So this is the in the sketch you have to draw it. Next we will discuss one by one what will happens in these strokes. Suction stroke, inlet valve opens and exhaust valve is closed. So as the piston moves from top dead center to the bottom dead center, the crankshaft rotates 180 degree, and piston movement creates increase in the volume inside the cylinder, which creates a suction pressure. That piston sucks the outside air fuel mixture into the cylinder, and there is a constant pressure is maintained. So these 3 points will happen, or process will happen during the suction stroke. Next is compression stroke. So what will happens in the compression stroke? So compression stroke, what will happen here, both inlet and exhaust valves are closed, piston is moving from bottom dead center to the top dead center, piston is moving from bottom dead center to the TDC to BDC to TDC. Crankshaft making rotation again 180 degree, from 180 to 360 degree rotation, and pressure, and due to compression piston moving upward creates the compression of that fuel air mixture, and that makes the temperature and pressure of fuel air mixture to increase and become hot. At the end of this compression stroke, volume remains constant for a small displacement. It is called constant volume cycle. Power stroke. In power stroke, both inlet and outlet valves are closed. That high pressure, high temperature air fuel mixture comes in contact with the spark plug, which ignites that air fuel mixture, hot air fuel mixture, and that burning of that high fuel air mixture releases high amount of energy. That high amount of energy gases push the piston downward, creating a movement from TDC to BDC, and the power is developed this during the stroke, which is stored in the flywheel. Exhaust stroke, in that exhaust valve is open and inlet valve is closed, piston is moving from BDC to TDC. Due to this, the inside volume decreases and the inside burnt gases escape to the atmosphere from the cylinder through exhaust valve, and crankshaft makes again rotation in the overall 4 stroke, the crankshaft making 2 revolution for generating 1 power stroke. So this is a 4 stroke petrol engine. And again the same, if you see the 4 stroke diesel engine, the only difference here, fuel injector will ignite the fuel, and instead of petrol air fuel mixture, here only fresh air will enters. That fuel injector will sprays the diesel on that hot air, burning of the gases will takes place. Everything is same, so that will see step by step. So the 4 strokes are suction, compression, power stroke, exhaust stroke. Suction stroke, inlet valve opens and exhaust valve is closed. Piston moves from top dead center to the bottom dead center, so that crank makes 0 to 80 degree rotations. So due to piston movements from TDC to BDC, inside volume increases, which sucks the outside fresh air into the cylinder. Compression stroke, both inlet and outlet valves are closed. Piston moves from bottom dead center to top dead center, BDC to TDC. Again crank makes 180 degree rotation, from 180 degree to 360 degree rotation, you can observe in the sketch. And due to compression, the pressure and temperature of that air will increases. At the end of that compression stroke, pressure remains constant for a small displacement of the piston. It is called constant pressure cycle, and compression ratio is 1:20. Power stroke, both inlet and outlet valves are closed. High pressure and high temperature air catches or ignites the fuel, diesel fuel, which is sprayed by the fuel injector. Due to that combustion, high amount of energy is released that pushes the piston downward direction. So flywheel stores the energy. The piston movements, high energy gases move the piston downward from TDC to BDC and creates the power or high energy. That energy is stored by the flywheel. Exhaust stroke, exhaust valve open and inlet valve closed. Piston moves from BDC to bottom dead center to top dead center, and that burned gases escape. Due to piston movement, the volume goes on decreasing inside the cylinder, so that burned gases escape from cylinder to the atmosphere through exhaust valve. Again here same, the crankshaft completes 2 revolution for making 1 power stroke. So this is overall about working of 4 stroke diesel and petrol engine, and the remaining 2 stroke petrol and diesel, and difference between SI and CI engine and 4 stroke and 2 stroke engine, and performance of IC engine and problems we'll study in the second video. Thank you.